I've got a treat for you today. I've got someone who I've been wanting to speak to for a while, someone who has been really into, software for as long as I've been a developer, much longer than I've been a developer, and someone who's now making his mark on the agent space. We have Uncle Bob Martin live and in his bathrobe, ready to throw down. Uncle Bob, hello, welcome.
Hello, and thank you. Good to be here.
It's great. It's great to have you. It's great to have you. For folks who don't know the bathrobe thing specifically, we should probably caveat that. What's going on there, and why is the bathrobe become an important part of your character?
It happened, I think 2 years ago. I was on my front porch in my bathrobe. It was 6 a.m, and I started thinking about how awful SQL was because of all the SQL injections, and makes no sense to have a textual language as your database access for security reasons. And I was in my bathrobe at the time, and I just pulled out my phone and I ranted, and that became the morning bathrobe rant. Apparently it was popular, so I did it a few more times.
So is this the mood that you've come here today? And is this the Uncle the Uncle Bob ranting?
Imagine it's early in the morning. I haven't had my coffee, and just don't bother me.
6 a.m. thinking about SQL, man. 6 a.m. Come on.
I'm done with this now. It's actually 10 a.m. The bathrobe's off. I have had my coffee. I'm on my first Diet Coke, so I'm fine.
Very good. Okay. Well, now the polo shirt is out. What's the Uncle Bob story? There are probably some folks, most of my folks are developers, but some of my folks are not developers as well in this audience. How do we introduce Uncle Bob, the phenomenon that is Uncle Bob, to especially non-developers?
Phenomenon? I don't know about that. I'm a programmer. I've been a programmer for a very long time, over half a century at this point. My first program was in 1964, and I was 12. and the program was a little model computer that my mother had bought me for my 12th birthday. Nice. And you programmed it by putting little white tubes on pegs. It was essentially a 3-bit finite state machine, but it fascinated the hell out of me at the age of 12.
Okay, so you're 12 years old. How do we get to 50 years later, Uncle Bob doing his thing now?
Yeah, a little more than 50. Let's see. Well, I just started learning as much as I could about programming. My father bought me a book about Fortran, a book about COBOL, a book about PL1. I read them all, had no machines to execute anything on, so I wrote programs on paper and executed them in my head. Got a job writing a little bit of code at the age of 16, but that was a temporary thing. Then I got a real job at the age of 18, and I've been a programmer ever since.
So you've been in the trenches for a long time, and you wrote rather an important book, I think.
A few. One of them I think was important. I've written a few more, but one of them seemed to take off. That was a nice one.
Yeah, and the cleanliness of code, if I remember correctly,
clean
code.
Yeah. Here's the second edition. This is the second edition, but
I mean, it's maybe the most certainly when I have conversations about good books, it's for software engineering, it's the one that most often gets quoted back at me. Like, it's incredibly popular, incredibly influential. So, and that's why I'm interested to talk to you today, because you've had this big influence in the pre-AI era, and you've been working in the pre-AI era for almost as long as it's existed, virtually. Now, how have things changed for you, Uncle Bob, now that AI is out there and is a thing?
So this took me a little by surprise around December of last year, Christmas time. And I'm just fiddling around, and I'd already been playing with, ChatGPT and a little bit of Grok and a little bit of this and a little bit of that. And I hadn't been real impressed. And then I went through a period where I thought, well, maybe these things are a little more interesting than I thought. And I got an agent. First agent I got, I think, was Grok, early Grok. It was an early Grok one. And I just asked it to write me some code, and it did a kind of a poor job, but it wrote the code. And I was in the middle of a project at the time. So I said, well, maybe this thing can help me with this project. And I started having it work with me on the project. And I was cleaning up after it all the time. It's just, it was always making a mess. It was always leaving a little dog do behind. And I thought, it's interesting because it's fast, but it's frustrating because it makes me slow.
Yep.
And then I started thinking, well, wait a minute. Because it's fast, it can do things that I cannot. So in the very early 2000s, there were a couple of innovations that caught me. I thought, ooh, these are good ideas, but they were completely impractical. One of them was called CRAP. It was it's an acronym. What can I say? Yeah. But it was a way to take code coverage. So you would run code coverage, test coverage over your code, and you'd also measure the cyclomatic complexity of every function, and you would mix those two in a complicated formula, and out would come a score. And the score was a measure of how crappy your function was. And way back in the early 2000s, I thought, this is a great idea. And I ran it over a big project I was working on. And yeah, there was a bunch of crappy functions. But then it took me forever to go through every one of those functions and try and fix them and rewrite the tests. And it was all working. So I didn't think I really could afford to do that. So although it was interesting, I kind of set it aside. And another one of those innovations was called mutation testing. And this one really caught my attention too, because in mutation testing, you have a little program that runs through your source code and flips negative signs to positive signs and less than signs to greater signs and equal signs to not equal signs and other things as well. And for each of those flips, it runs your entire test suite and expects the test suite to fail, because obviously they've changed something significant. And if it doesn't fail, well, that's a surviving mutant and it must be killed. Now, I ran this again over that same project right around the year 2000, and I had to run it overnight because the test suite ran for 4 minutes and I was running it maybe several hundred times. But it came up with a bunch of surviving mutants, which I was able to fix. But once again, it was impractical. I could not put that as part of a normal build scenario. And so I'm sitting there last December, or maybe it was January by this time, and I'm thinking, well, wait a minute. These guys are fast, and they don't care how boring the work is. And they will do what I tell them to do. So why don't you run crap over everything you've just done? And it would run crap, and then it would clean up the code. And I was watching it do this. I think, well, that's pretty cool. And why don't you run mutation testing too? And it would run the mutation testing. Maybe it took it 30 minutes instead of an overnight run. And then it would plug all the holes and make sure there were tests covering everything. I thought, this might be a way to clean up the dog do. These things leave a lot of detritus and fluff behind, but maybe this is a good way to clean up all the dog do. So I continued on this path of adding more tools and continuing to work with these agents. And I got them to a place where they were doing a pretty good job. So nowadays, my principle is, I will set the agents working. I will have them run these tools, and I'm going to work very hard to get it into a situation where I don't have to look at the code at all. Mm-hmm. I can trust what they do. And now I do other things to verify that the code is still decent. I will look at the crap scores and make sure that they're low, and I will do spot checks on the code from time to time. And I have a whole bunch of other tests that I run. But overall, that's my goal. If these things are fast, and they are, and if I can constrain them to do a good job, then I am not going to impose my slowness upon them. And my slowness is reviewing the code or inspecting the code at some kind of level of detail. They are fast with code. I am slow with code. So I'm going to let them have the code, and I'm going to deal with the stuff around that to make sure it's all okay. So far, so good.
So your goal is to start pulling yourself away from the code, away from human review, to construct this scaffolding around the code so that you don't have to interact with it much yourself, and so that the agent is constrained as much as possible in as tight a straitjacket as possible so that it can't make a mistake. I think there's an assumption there that I want to touch on first, which is that the word dog do, right? It doesn't sound good in a British accent. Dog do, you know. So why is dog do bad? Why is bad code bad? Like, why do we care about that? Because these things are so fast and they can move so quickly. Why do we care? Why are we bothering with all of this harness? Can't we just push through until the bugs just disappear?
One of the things I noticed really early on, like December-ish timeframe, was that I'd be working with the like this little grok agent, and I'd have it do something and it would leave all this mess around. And instead of cleaning the mess, I would have it do the next thing. And it would leave even more mess around. And then I would have it do the next thing. And I noticed it slowing down. And I noticed it having difficulty. It would get into a mode where it would change one thing, but inadvertently break another. And then it would have to fix that, but inadvertently break another. It started going around in circles. And I thought, okay, these agents, they may be fast and they may be relatively smart, but they are as subject as humans are to messy code. Now, maybe not as subject. Maybe there's a difference in threshold, but the threshold is still there. The code can get messy enough that the agents cannot deal with it any longer. And then they'll just start to spin and make a mess even worse and be unable. I've actually had them just give up. One agent one time said, "I just can't deal with this anymore." I'm paraphrasing. It didn't use those words, but that was obviously what was going on.
Yeah. So your response to that then is, how can I clean up the crap? And I think when most people encounter that, they start loading the agent with instructions, right? They start saying, okay, I'm going to pour in information into the agent that's doing the implementation, right? I'm going to pile in on Claude.md or agents.md. And every time I see something bad, I'm going to use an instruction instead of what you're doing, where it's a deterministic mechanism. So you're using automated checks, whereas a lot of other people are using, in my terminology, steering, right? They're trying to steer it. So why didn't you, are you doing any steering, or like, how does that work in your mindset?
So initially I started with that. My early prompts were, here's how you do test-driven development. Here's how you do clean code. Here's what your code should look like. You should follow all these rules. And, you come up with eventually a document that's 5 or 10 pages long, describing all the good things about code. I suppose I could have fed the whole doggone book into it. Mm-hmm. But what I noticed was that the agents, the models, whatever you want to call them, they treat those rules in the Pirates of the Caribbean sense. They're more like guidelines, might follow them.
Can I just credit you? That's exactly the metaphor that came into my head as well. So I'm glad we're aligned there.
Yeah, well, so they definitely will soften, and there's technical reasons behind this. I did not a lot of research, but some research into why the models behave this way. And it turns out that there's this phenomenon known as lost in the middle. So as the context window builds up inside the model, the stuff at the very beginning and the stuff at the very end have more prominence than the stuff in the middle for technical reasons. But once again, the agent will ignore the stuff in the middle, and anything you say at the very beginning is going to get shoved into the middle if it's long. Right? So maybe the first 3 sentences you put at the beginning will remain as priority, but the 50th and the 80th sentence in there, they're gone. They're just in the middle somewhere. And the poor agent is trying to deal with this massive context that's ever growing, and it's trying to pull the important bits out, and the stuff in the middle is just gone. So deterministic tools don't disappear that way. the key that I think with agents, and this is really hard to do, the key with agents is to trim that initial prompt down to its absolute minimum so that you can get as much of it as possible into its priority.
Yeah.
Right. And then do deterministic tools after the fact.
Totally. I refer to this as like the smart zone and the dumb zone of the context window. It's not my term. That's Dex Horthy's term. I stole it and it's very, very good, which is especially at the early part of the context window, like the first 150K tokens, it's pretty smart. But then as you go along, then the attention relationships in the transformer get really strained. It's really diluted. It's like everyone's shouting. Each token is shouting in a crowded room and the room's getting more crowded, right? You can't hear the signal for the noise. That totally rings true for me. So you sort of rejected steering and you sort of started going back to some old techniques in automated checks. Now, it sounds like then, because those checks don't go into the context window in the same way that steering instructions do, you can kind of just layer those on, right? And layer them up and up and up. So if you're using a language with strong types and like tests and like, how does that picture look to you? Is there ever too much when it comes to automated checks?
That's one of the things that I'm working very hard to figure out. And obviously, there has to be a case where there's too much. Right? Eventually, you will slow the agents down to the point where they're slower than humans. And at that point, you've lost the game. Why do it? But as long as you can keep the margin of productivity higher than a human, you're still ahead of the game. And from what I've seen so far, I can get that margin, like a factor of 2 or 3 or 4, right? They'll still go pretty fast. Now I'm slowing them down a lot. When you use these deterministic tools, what you are really doing is you're putting them into a loop. Lots of people like to talk about loops nowadays. You're putting them into a loop, and you're saying, okay, you must change the code until this tool says that it's okay. And now the agent is going around and around and around. Okay, I've got to do this. I've got to do that. I've got to add more tests over here. I've got to cut the cyclomatic complexity. I've got to split these functions apart. I've got to do all this work. And it takes it a while to do all that until it gets it into conformance. So you are sacrificing productivity for higher quality. And at some point, that's got to give way. But I haven't found the end point of that yet. So now I'm in the midst of trying to get multiple agents talking to each other and handing off to each other so that one guy does one thing and the next one reviews it and the next one tests it and the next one hardens it and so on. And there's communication overhead like crazy in that. And yet it's still faster by a large token than a human.
Let's talk about that. Let's talk about multi-agent systems, because I find that super fascinating. I have always had a bit of and I think this might be something where we differ, which is I've always had a bit of a suspicion of like people who say, I've got rid of all my workforce. I now have 100 agents. Every one of them has a different role. They all talk to each other. They've got their own email accounts, all that rubbish, And so for me, what's always worked, but okay, I sort of make an exception when it comes to implementation and then review. Right. And I think the benefit there is not having 2 very specialized agents. It's having, okay, you do the implementation and it's kind of like a red-green refactor approach, which is the implementer. All it has to do is just like write the bad tests and then make it work. It doesn't have to make it beautiful. And then the reviewer comes in. It doesn't have to do the exploration because it's already got the diff from the implementer. It knows exactly what it's reviewing. And then you can pile in quite a lot more steering instructions in there because the task is much less constrained. So I'm really interested in your take on that, on like what the implementer does, what the reviewer does, and what these other hardener agents, I've not experimented with that. Give me more on that.
So there's 2 advantages to having multiple agents like this. The one is that you can run them in parallel. So you could have, 3 coders running at the same time. And my little laptop can support a lot more than 3. The other advantage is that when you focus the agents down to a single task, you're keeping the context window under control. The lost in the middle problem becomes much less of a problem. So you can pile a few more, not a lot more, but a few more rules up at the top, and they'll tend to follow them better. You can also set up a system where the agents are born, do the task, and die, so that the next one comes in with a clean context window. So those are the advantages. The disadvantages are that the startup times are high, right? So an agent takes, 10, 15 seconds to even start up. And then it's got to figure out its whole context all over again. So there's that particular startup time as well. I like to focus the task as much as I can. So I will run a specifier. The job of the specifier is to take a human written document and turn it into a gherkin and a QA procedure. Gherkin is, given when then stuff. It's a high level acceptance test. And a QA procedure is essentially a system test. You run the system through the UI with a QA procedure. And I have them write it from a human's point of view. You are a human. You are operating this system at the UI. You must prove that the system works. And I will produce those two documents, Gherkin documents, QA documents. And then those feed into a coder. The coder's job is to write unit tests and the code that implements the described story, and also get the Gherkin working. So it has to do that. And then that gets fed over. Once that's working, the coder will work on that for a little while. That gets fed into a cleaner. And the cleaner's job is to run crap analysis and just general code review. Clean up whatever mess the implementer made, because the implementer will have made a horrible mess by that point. And then I have it go from there to a hardener. The hardener is the guy who runs the mutation testing, and he's absolutely merciless, right? It's going to mutate it, and it's going to have 100% coverage, and every equal sign and every less than. It's going to do that work, which takes a good long time. And it pops out the end, and then it goes into a QA agent. And the QA agent takes the written QA document, turns it into an executable script that manipulates the system and comes up with a deterministic result. And if you can get through all of that, you've got a pretty working program. I've had a lot of success with this. If I give it a task that takes a single agent 5 minutes to complete with questionable results, this will take it about an hour. It'll take about an hour to go through all that, which is still a benefit, because a person would take about a half a day. So maybe I've got a factor of 4, factor of 5 improvement in productivity, and very high quality, much more quality than the human would ever put into it.
And it's not only that, but you're saving productivity, or you're spending productivity early to gain it later.
Yes.
Right? This is an investment in your own code base. Yeah. What I found really interesting about that is, this is something I've been thinking about recently, is it's not only the context window that you're manipulating, there's this idea of a trajectory of a context window, right? Of a session, where if you get the agent to do one thing and you steer it in a certain way, then everything that follows in that same session, that same context window, will continue following that trajectory. So if you get it to say, okay, maybe we should test the UI here, then every single time it will test the UI again, no matter how many changes you get it to make. And the only way to clear the trajectory is to clear the context window, right? So if you're an implementer agent and you're just trying to get it working, then your trajectory is it's not quite as harsh as the one who's trying to make sure you have 100% coverage. And I found that really interesting. Is that something, does that click with your mental model as well? Yeah,
it certainly does. There's a pretty well-known effect with these models, and it happens with people who aren't programmers, right? So you're talking to a model about, I don't know, what's the best coffee to have, and how do you brew it nicely? And you're having this nice little conversation with the agent about this, or with the model about this. And then somebody walks by and they happen to be talking about the latest soap opera that they saw on television. And that gets into the context window. You didn't put it there. This guy walking by put it in there. But then from that point on, all the coffee references have to do with the soap opera, right? the model doesn't know. It can't differentiate. So your idea of trajectory is pretty good, right? As long as you can keep the direction of the model unconfused, it knows the direction it's going in, everything in the context window is consistent, then it's not going to have these crazy hallucinations that people often deal with.
Or even just misalignment, right? Like I think hallucination is always a danger, right? Like whether it's, hallucination context you gave it, whatever, like it's sort of an accepted danger. And your approach of this kind of gauntlet of different agents slamming horrendous stuff is is a great way of taking out that. So, okay. You've talked a lot about the implementation phase, and we can get back to that later too. What I'm also interested in is what planning do you do up front? And especially, how are you thinking about the internal structure of your code bases? Because having a good test suite, right? I mean, I'm interested in what you think here. Having a good test suite is good, right? Having mutation testing, all that stuff is good. But if you've got badly designed APIs, if you've got badly shaped modules, how does that interact with all of this automated checks and stuff? Like, how much are you thinking about that?
So up to the last month or so, what I was doing there was doing that part manually. So I would have the agents build me up a nice thing, and then I would interrogate the agents. And this was manual, but still using the agents, right? I'd interrogate the agents. What's the structure here? How does this module interrelate with that module? What are the modules after all? And how do they talk to each other? I would ask those questions. And then I would get scared to death because the answers were horribly frightening. And then I would design a module structure. And I would tell the agent, okay, here's how the modules should really be partitioned. And here's how you should communicate with them. And I would give them an implementation plan that they would then implement. Now, that's a tough one. So I also had my agents build me an architecture viewer. So I can pop up on the screen a nice little UML diagram, essentially. Nice little UML diagram that shows me the modular structure of the system and where the dependencies run. And I can click on a module and I can see inside it to the submodules. And I can click on the submodules and it'll actually pop the code up on the screen for me. So I can drill down as much as I want and view the system architecture at any level. That was really useful to me, and I've made good use of that. I've also put together another deterministic tool where I can define which module should depend on which one should not depend on which, how the dependency should flow. That goes into a nice tight little specification file that the agents cannot violate. So it's another little checker that runs at the end. And if they violate it, they've got to fix it somehow, usually by inverting a dependency or inserting an interface or splitting a module in half or something like that. And it will keep my rules from being violated. I'm working now to see if I can automate that. And I'm having not a lot of luck so far.
Yeah. I'm basically in exactly the same boat as you, which is you just get so much leverage by having well-designed modules, right? Could you explain what that leverage is? Why is having a good structure for these modules important?
Well, it's the same argument that we had for the dirty code versus clean code. Anything that is well partitioned with well-disciplined interfaces between it is something a human can grasp because we compartmentalize in our minds. Well, so do the models, so do the agents. Maybe at a slightly different threshold. I don't know about that yet. But they work far better if they can focus on a module and if that module has a trajectory, right, using your term, so that the model does not get confused by the topics inside that module. Okay, I'm using the word model and module. I want to be clear.
We get it.
But that's important. And it's the same argument. It's the coffee and soap opera argument. If you load up a module with every bit of stuff under the sun, the poor agent is going to wonder, what the heck am I doing in here? How do I do anything in here? If you compartmentalize nicely, works pretty well, just like a human.
So you're probably getting better value out of your test suite as well, because that's what I always think is like, okay, I suppose here's another question for you that's related to this. I think of, and I'd say I'm a huge fan of your work, but I'm also a huge fan of John Ousterhout's work.
Yeah.
Where I mean, who isn't? A great guy. You probably got his book around somewhere.
I do.
And his concept of deep modules is something I find really fascinating, which is you can have bad modules, which is kind of shallow modules, right? That have a wide interface and not much hidden inside them. And you can also have deep modules, which have a small interface and then a deep, lots of hidden information inside them. And it occurs to me that that is really good with models because they can read the interface without having to understand the implementation. Does that sort of chime with you? And is that how you're approaching things as well? Yeah,
absolutely does. The models pay attention to interface names. They pay attention to the structure. It can allow them to not read the code beneath them, which is both a danger and an advantage.
Yep.
As long as the code is consistent, you're okay. They also pay attention to the tests. They read tests to understand what the system does. So yeah, anything you can do that helps the structure of the code will help the models understand that code. By the way, in this book, there is a long debate between me and John Ousterhout in the appendix, and it was a lot of fun. He and I had a blast. Well, I don't know how much fun he had, but I had a lot of fun.
I watched the entire thing. I saw you guys interviewed on a really great YouTube discussion where you talked about it, and I just loved it, and that's kind of the reason I wanted you to come on, actually, because I just enjoyed that so much. Okay, there's a few different ways I could go now. Okay, is there in your book anything that you would change or update now? Because specifically, I'm thinking about some advice like create small functions, let's say, and keep functions small. Is there anything that you're sort of, because we've been talking a lot about how things have not changed, right? How gauntlets like this have always been good. We've just never had the labor available to actually push through them, right? These ideas have been good for a long time. We're just sort of modifying them in a different way. But is there anything that we just need to, and this is, I suppose, a wide question, is there anything that we need to throw out that's just like done? Or is there anything that's, I don't like asking this question because it puts a lot of pressure on you, but do you have an answer for that one?
So thresholds, for one thing. It seems to me that the agents can deal with different levels of complexity than humans. They have a much better short-term memory. I mean, a huge short-term memory and a perfectly accurate short-term memory. So one of the things that I do is I widen the allowed size of a function. And I do that by adjusting the crap score. So for a human, I would keep crap numbers below 4, right? But for the agents, I've set this at 6, and I'm thinking maybe I'll push it to 8. I'm trying to find where the threshold is, and it's not an easy threshold to find. But
what does that look like in terms of 4 to 8? Like or 4 to 12? What's the difference there? Like, is it like a 20-line, 100-line function?
So it really boils down to the cyclomatic complexity, which is the number of pathways through the function. And if you've got 100% coverage, then a crap score of 6 means that there are 6 pathways through the function. They're all covered with tests. So that's really the goal of crap, right? Get it all covered with tests and then limit the cyclomatic complexity. And I've had a number of debates with the agents. And by the way, you can't trust any debate you have with an agent, but I still have them anyway. And they seem to think that, 6 is probably pretty good. Well, I don't really trust them, but okay. But I think there's a threshold difference there. There's another factor. In my books, I talk about disciplines. One of them was test-driven development. I'm a big advocate of test-driven development. But that's a human discipline. That's done because humans are wired a certain way. I cannot and will not enforce that on the agents. I don't think it makes any sense to make an agent write a single line of a test and then write a single line of the production code and then the next line of the test. I don't think that makes any sense. For a human, it does, at least for me. I mean, there's a huge benefit from my work. But for the agents, I don't think so. So I allow the agents to behave more like John Ousterhout would. which is to write a function and then write the test for that function, and then write the next function and write the test for that function. I allow them to do that. Even when I have told them to do test-driven development at high discipline, they always fall back on doing that. They always end up doing that. So I figure that's probably okay. So the bottom line there is, it's probably a mistake to impose a human discipline on an agent. It is not a mistake to impose human values on the agent, but there may be thresholds that we need to change. But the disciplines themselves, the behaviors, I don't think it's wise to impose those.
That's a lovely way of phrasing it. I really like that. So it's a short-term memory thing, right? Because TDD is great when you have very low short-term memory, like humans, right?
Yeah,
you have enough short-term memory to write the test, and then enough short-term memory, just enough to make the test pass, right? You can go out and get a coffee or something. So, okay, that was great. Thank you.
You're welcome.
Okay, we've talked a lot about building the thing right, right? And building the implementation, right? And doing modular architecture and that sort of thing. What do you do before you kick things off to your specifier? How much planning are you doing before you actually go into this gauntlet loop? Because like putting the wrong work in a gauntlet is super wasteful, right? How do you think about that?
Well, so the temptation is to specify. You know, get the human to specify, and then give it to the agent. This is a very old temptation. It was a temptation we underwent in the 70s. It led us to the waterfall process and all of that. And the Agile Revolution was the answer to that, or the answer back to that. I don't know how well we're doing with the Agile Revolution either, but it was a way to say, wait a minute, all this heavy upfront planning makes a mess of everything, because what comes out at the end doesn't look anything like the plan, and never has. Well, the temptation with agents is to do the same thing, right? Okay, we're going to plan. Then we'll give it to the agent. And I have tried this. In fact, I've been in the middle of trying this just this week. And it's always a disaster. It's always the same outcome, right? You make all these plans, and then as the agents are running, you, the human, realize that they can't follow that plan because you didn't think of everything, and they're not as wise as you are. So they're running half-cocked off on some nonsense that you have to stop, back up, rewrite the plan, and then start them over again. And so I've given up on that. I said, okay, wait a minute. Let's try the Agile approach now. And I don't know how this is going to work out. It might not work out all that well, but let's try the Agile approach. Let's just let them do a story or two, and then we'll look at the architecture at the end, and maybe I'll have to manually get involved and sort a few things out, and then a few more stories and so on. That might be a better approach. We may never escape that manual organizing step at the end. Although I'm trying to figure out a way to do it, but I don't know if that's possible.
I think of it like you've got this huge chunk of labor that needs to happen, right? In the old days, this was building the thing, right? And building the thing would take days, weeks, months, maybe. Yeah. Now that has shrunk, right? But the planning up front and then the review is still the same, right? We're expected to do these fast iteration cycles as devs, but the stuff that was actually quite hard is still kind of the same and takes the same amount of time. Building the wrong thing is something that you can still do. And I totally agree that there's like this sort of, a lot of folks are doing this kind of plan maxing thing where they're just, they take their spec and then they think about their spec, they run their spec through 7 different agents or something. And then they get back a better plan that they then go and implement or something. That not sound good?
The agents love to write plans. Oh my goodness, they love it. And they will embellish the plans, and the plans will be gorgeous and beautiful and spell out all kinds of details. Yeah, and then they fall apart at the end. Yeah. I think you can see it in the industry right now. There's this movement towards spec-driven development. And My impression there is that that's probably not going to work. My experiments did not work particularly well. And I'm thinking now maybe we should once again look at the agile ideas, and maybe the idea of do a little bit, get some feedback, do a little bit more, get some feedback, reorganize, do a little bit more, feedback, reorganize. I used to tell this story back when I was doing agile lectures. If it cost you $1 to make a change to a house, including the initial laying of the foundation, the initial roof, everything, every change you gave to the contractor would cost you $1. How would you build that house? Would you hire an architect and pay thousands of dollars to the architect to come up with a perfect plan that they then paid $1 to the contractor so that he could build it in one shot? Or would you walk up to the contractor and say, I want the foundation here, make it that shape? Oh, no, that's bad. Okay, let's change that foundation. Let's do a little different. Put the kitchen over here. Put the living room there. There's $2. Oh, heck no. Let's change those around. Let's let the kids walk through the traffic pattern is crappy. Move the stairs around. Obviously, the latter is probably better. And that's what we are looking at right now. It costs $1. Well, maybe $2, maybe $5. But the cost of change has plummeted to as close to zero as I think we're ever going to get it. And well, that's a prediction I'll probably lose, but still, right? The cost of change has gone so far down that why would you do this upfront planning? Because that's expensive. Why wouldn't you just fiddle until it looks right?
Yes, I 100% agree. I couldn't agree more. The thing I think I have a massive issue with the spec-driven development label, because what is spec-driven development, right? Like you can have like 10 different interpretations of it, and every time you pass information to an agent, right, is prompt engineering spec-driven development, right? Like it kind of is. You would say to your, if in the old days you would have like your mate over the other side, your colleague, and you would say, you just fix that loading issue in the header or something. Is that spec-driven development, right? Like, is that a specification that I've given him, And it seems like every time I say, okay, do a little bit of upfront alignment first, that approach then gets called spec-driven development. But for me, I think the difference is, are you persisting your specifications, right? Are you returning to those specifications? So what's your attitude there? Like, do you keep like a list of all of your specs in the repo, or do you what's going on there?
No, I do not. The specifications are ephemeris. They go away. They change a lot. I fiddle with them, and that goes away. There is no equivalent to source code. We humans wrote the source code, so that was the final specification. Well, that doesn't exist anymore. There is still source code, but we humans aren't the ones writing it. And a lot of people feel that lack. There has to be a human thing that defines everything up front. Well, I mean, in the end, even what the agents produce was produced by humans. The thing that I've been doing lately is this. Instead of creating a specification that defines what I want, or defines what I have even, I look at the end result and say, well, that is the specification. So I've got a bunch of tools out there. I've got like the crap tool, runs for Clojure, runs for Java, runs for Go. I wrote a few of them, right? I had my agents write them. I've got the mutation tester. I've got my agent harness. I've got all these things up there. What I tell people is, don't download those. I wrote them for me. What you should do is point your agents at them, have the agents look at them, and then build one for you.
Yeah. I
think that's a far better way of specifying the essence of something and then customizing it to your particular need.
Yep. It's what I always find weird about agents is that if you send them something, they read it, right? Which is very different to humans, right? Very different. You can maybe get a 20% hit rate if you send someone a massive specification, and 20% is maybe a bit generous, 5% maybe. If you pass a spec to an agent, they're probably going to read it. Right.
The opposite side of that is the things that the agents write, the humans don't read.
Yes, exactly. Yeah, exactly. So they're expecting, I hadn't thought of it like that. They're expecting us to read everything they write, and we just don't. God, that's funny. It's so one-sided, you know. Long term, I'm interested in how human relationships differ or get different because we're so used to communicating with agents, right? I dictate to my agent, so it's like I'm just sort of talking to a friend or something. I'm really interested in sort of how life imitates art over time and stuff. I don't know. That's fascinating to me. So, okay. I think I'm going to ask you maybe the final question, and it's a sort of fairly beefy one.
Okay.
If that's all right.
That's fine.
Final-ish. I'm going to go John Ousterhout again.
Yep.
Because John has a great definition for different types of programming, right? You've got the tactical programming. Are you going to get it?
I just have to. You've mentioned it too many times. I've got to pull this book down. It's here somewhere.
Where's mine? I've got mine.
Oh, good. Okay. All right.
Okay. I got mine.
Oh, there it is. Yep. Okay.
There, got it. Whee!
Okay.
Done. Tactical versus strategic programming.
Yeah.
So tactical is the sergeant on the ground, the person kind of fighting the battle. The strategic stuff is the general, kind of the person directing the course of the war. Now, I think we both agree that's a good framing, right, for different types of programming. And agents are really good at tactical, really bad at strategic. Now, for people who are just starting out, and AI has now eaten all of the tactical stuff, how do they learn to do strategic programming? Because I think a lot of people here, that's kind of what they want from you, Bob. They want, please just give me your brain so that I can inject into it, understand why mutation testing is so good. Tell me how to explain these modules. Like, that's what they want, I think. So that's your job now, is to give people your brain. How did they learn that stuff?
Okay, so I get this question a lot. I don't have perfect answers to it because I really don't know, but here's how I would think about this. Here's how I do think about this. First of all, the way a programmer should learn, whether it's in university or somewhere else, right? It should be to write code. You should be writing code, right? For a year. I don't know how long, but you should be writing code so that you know what the agents are dealing with. The next thing that I think should happen is that when you get hired into a company where that company is making heavy use of agents, you, the young person just coming out of training, should be treated like an agent. The guy who's running maybe the lead engineer or whoever, the guy who's got a bunch of agents running and he's being strategic, he should look at you as an agent. And he should give you the same kind of tasks that the agents have and subject you to the same kind of deterministic tools that the agents have to use. And you should spend several months in that state, being horribly unproductive, but learning a hell of a lot. And by the time you've gone through that gauntlet, maybe you can be trusted to run an agent of your own. Now, I don't know. It's going to be something like that. You cannot lose the code entirely. I used to tell people 10 years ago, if you've never written assembly language, you should spend the weekend writing assembly language just so that you know what's really going on behind the scenes. Because if all you're doing is writing Java all day long, you live in a fantasy world. There is still magic that you don't understand. Spend a weekend doing assembly language and you will finally understand what's really going on. And I think that remains true. Somehow during this educational pathway, you've got to go from the basics, binary, all the way through assembly language, some basic code like C, some higher level code like Python or something, and then deal with agent kind of work and deterministic tools, and finally be able to strategically run an agent under supervision.
Yeah.
I don't know how better to say that.
It's so hard though, right? Because there's two things going on there, right? Like there's the agent is a kind of abstraction layer, right, over the code. And so you got the code, and then it's interesting, you were talking about an abstraction layer like a sort of module viewer, right? Like, I think that's super interesting. That's a really good way to learn, getting these kind of abstractions over the code so that when you dive in, you understand it more deeply. But if you have someone who's just like sitting on your books, just doing tactical work, surely as a company, you're going to look at that and go, why are we hiring this person when we've got Uncle Bob's swarm of 5 hardeners and stuff that can beat it, at a fraction of the cost, right? I'm so, okay, what like resources or books or approaches sorry, there's one more question here, which is, I'm trying to like work out how people get this information, because the feedback loop on strategic programming is so long, right? Or traditionally it has been very long.
Yep.
So you can often, like, people who just like quit jobs after 6 months or something, they might never learn strategic programming, right? Because their mistakes are maybe 9 months away, so they just never see their own mistakes. But I think with agents, you can, right? Because it's sped up so much, you can actually get more feedback on your mistakes sooner. And I suppose what I'm interested in is, how did you know that your agents were making mistakes back in December when you were looking at them and going, this is dog do? How did you identify that?
Early on, I was just looking at the code and seeing the dog do. That wasn't the important part. The important part was the next step, where I watched them thrash. I could see the agent struggle, and I recognized the struggle, since I have been through that struggle, right? And that's one of the issues, is the novice would come in and not recognize the struggle. Now, how do you learn that? How do you learn, I learned it the hard way, School of Hard Knocks. How do you learn that as a young person coming in? How do you recognize that? There is a wealth of information about this. The old books, the ones that nobody reads because they're old, the old books on this topic are terrific, right? You go to the works by Tom DeMarco or the works by Ed Jordan, or go read, jeez, I can't think of the names right now, but
Pragmatic Programmer,
the
classics,
the Pragmatic Programmer. There's a lot. Yeah. There's a lot of these older books. They're very good. That if you study them when you're young, you will get a feel for what this higher level strategic play is. You'll have to filter out some of the archaic stuff, because a lot of these books were written in the 70s or the 80s, right? But that's when these lessons were learned. And so, that's where I would go initially. I would go to those books and learn that stuff that way. And then, of course, you're going to have to learn it by feeling it.
Yeah.
That's why I think they ought to play agents for a few months, so they can learn what that's really like.
Become the agent. Have the agent delegate to you. Yeah, you become a sub-agent of the agent. I like that. So, okay, I do have one more question. It's, I suppose, a short one.
Sure, it's fine.
Which is, sounds like then software fundamentals still matter, right?
Yeah.
And why is that? And what do you say to the people who say that they don't matter?
Why is that? Software fundamentals matter for the reason they have always mattered. Let's see, who said this? It was Dijkstra, I think, who said it. I'm gonna get this wrong, but software is the most complicated thing that humans have ever attempted to do. More complicated than any other task that we've tried. Software is the most complicated thing, and therefore the fundamentals are a way of organizing that complexity into a form that can be conceived, not just by humans, but by our models as well, since our models are modeled after humans after all. So the fundamentals still apply, because that's the way we organize complexity to be conceived, or to be conceived of. There are folks right now who think that the fundamentals don't matter. They will learn, and they will learn that the hard way, and it won't take very long. Might take longer than I think it'll take, because the agents are pretty good, but I've watched them hit the wall. So I know that wall is there, and I don't want to hit that again.
Well,
it's a very interesting set of parallels that we're in at the moment. You had mentioned the abstraction layer, right? And we're now at a level where we're above the compiler. We used to our abstraction layer used to be the compiler. Before that, it was assembly language. Before that, it was binary. And now it's up here at this level of the model. At every one of those steps, up the abstraction layer, the people at the lower step complained. Said, "Oh, this is going to ruin everything. We're not even going to have jobs anymore. It's become so easy that 5-year-olds will be able to write the code." And back then they were still talking about like binary. Yes. At every step, it's the same. And so we're at this next step, and the people down here are saying, "Oh, it's going to ruin everything." No, it's not. The same rules apply. All the same fundamentals exist for all the same reasons. The rules you throw away are the ones you're going to pick up off the floor in a year and dust off and remember why you need them.
Yeah. Thank you so much, Bob. There's a great quote from, I think, Plato, where he says that writing is going to make people stupider, right? So people have had that same abstraction argument since, the Greeks, right? Ridiculous. I think everyone watching, how many folks have we got on this stream? We've got 1,500 people watching. Incredible. I think we can all agree that was a fantastic conversation. Bob, thank you so much. Hold up your book one more time so folks can get it. Let's see. Clean code. And I think, it's 11 a.m. now, your time? Back to the bathrobe?
Yeah, it is. Yeah.
Perfect. So, folks, thank you so much. I'm going to end the stream here. Me and Bob are going to stay on for a minute.